Hey everyone, welcome to Data Engineers Launch number 61. Today's talk is going to be on KubeVirt, and today's talk is going to be given by Stefan Nikolovsky. He's an engineer here at Anant. Co-organizers for this event are Rahul and myself. If you are interested in giving a talk at Data Engineers Launch or also our sister launch, Cassandra Launch, you can reach out to me. My email is listed below, as well as if you're interested in sponsoring Data Engineers Launch or Cassandra Launch, you can also reach out to me as well. We're part of Data Community DC. Data Community DC believes in building an inclusive environment, so no matter your race, gender, sexual orientation, everyone is welcome, and we expect respect to be given to all. Data Community DC has built up a bunch of different organizations. If you're interested in all the various different organizations, as well as events put on by the various organizations, you can check out datacommunitydc.org. So what do we cover here at Data Engineers Launch? We cover everything from the ingress to egress of data, the data cleansing, the data wrangling, ETL, et cetera, et cetera, et cetera, as well as tools that help with data engineering, as well as data ops and how all that plays into building your data analytics pipelines. If anyone's new here or watching on YouTube, say hi, hello in the chat. Group roles, if you have a question, ask it. This is a community, so please do share what you know with us. So potentially if you've worked with KubeVirt before, if you have any comments or questions regarding it, feel free to drop it in the chat. If you're watching on YouTube, you can drop it in the live chat and we'll get them transferred over to the Zoom. Please do be courteous of the guest speaker. They may have preferences in terms of when they prefer questions, so the guest speaker will give their preferences when they take over. Here at Anant, we design, build, and manage global real-time data analytics platforms surrounding Cassandra, Spark, and Kafka. So data engineering is a way of life for us. DataStax is a partner and a sponsor. GW University helps provide venue space when we have in-person events. We also have some organizational and institutional sponsors. If anyone is offering a job, or if anyone's looking for a job, if anyone has any links, they can drop them in the Zoom chat or the YouTube chat, and we'll get them transferred to and from. Also, if anyone has any meetups, hackathons, conferences, or classes that they would like to promote, feel free to drop those below as well. DataStax Astra currently has a build-a-thon that's ongoing. The first round/month has concluded. The second round is currently ongoing. And for each month, there's a round of challenges. And the top 3 winners of each round qualify to present their ideas on demo day. So there's cash and swag prizes to be won at the month level, as well as the demo day level if you qualify. We'll drop the link below if you're interested in the YouTube chat and Zoom chat, so you can sign up. Anant is hiring. If you're looking for a full-time or part-time position as a data platform operator, engineer, architect, you can reach out to us at careers.anant.us. Upcoming events, Cassandra launches are held Thursdays at noon Eastern, and Data Engineers launches are Mondays at noon Eastern. We are looking at having a more variable time slot to cater to the live world. But again, all these videos are live streamed directly to YouTube. So if you're not subscribed to our YouTube channel, subscribe so you can always catch the replays as they get streamed direct, as well as you can hit the notification bell so that way you can be notified whenever we do go live. And with that, we will go ahead and pass it over to our speaker for today, Stefan.
Thank you, Arpan. Okay, hi everybody. My name is Stefan, and today we'll quickly talk about KubeVirt, this new technology based around Kubernetes that has been out there. I don't know how long it's been out there, but it seemed really interesting to me and to some people here in the company. So kind of decided to poke around and see what it does, what it's actually about. Is it that hard to set up to start with it? And if anybody has any questions or has worked with it, feel free to interrupt me at any time and talk about it. So first of all, let's kind of figure out what KubeVirt is. Basically, what they said on the website and what I deducted is that KubeVirt is an open source cloud-native computing foundation sandbox project that makes it possible to manage virtual machines on a Kubernetes cluster. Now, we all know that on a Kubernetes cluster, we kind of manage pods, which are in turn containers, right? So why do we need to do like virtual machines, and what's the benefit of that? Well, as they explain it, it's an example, if you want to have a hybrid of, let's say, containers and a virtual machine running on the same pod, then you can use KubeVirt to do that. And if you have a legacy system that still uses virtual machines instead of containers, because they are relatively new, you can use KubeVirt to just get all the potential power from Kubernetes for your virtual machine. Let's kind of talk about the architecture. You guys kind of can see the queued orchestration, Kubernetes, scheduling, Kubernetes. Then we have the runtime, the virtual, and then the physical. So users requiring virtualization services are speaking to the virtualization API, which in turn is speaking to the Kubernetes cluster to schedule requested virtual machine instances, VMIs, and we're going to take a look at a YAML file of a VMI later on. So scheduling, networking, and storage are all delegated to Kubernetes, while KubeVirt provides the virtualization functionality. That means that KubeVirt is more or less concerned with the functionality of the virtual machine, while we leverage the power of scheduling, networking, and storage that Kubernetes already has. Again, like with the scaling and the replication, everything that Kubernetes does, we can apply that too. Additional services. Okay, so KubeVirt provides additional functionality for Kubernetes cluster to perform virtual machine management. Basically, they have a great way of managing virtual machines on your Kubernetes cluster, right? So if we recall how Kubernetes is handling pods, then we remember that pods are created by posting a pod specification to the Kubernetes API server. This specification is then transformed into an object inside the API server of a type pod, right? So the object of specified type or kind, so we can have service, we have pod, and this is what is called in the specification. A pod is of the type pod, like I mentioned, and controls within Kubernetes know how to handle these pod objects. Thus, once a new pod object is seen, these controls perform the necessary actions to bring the pod alive and to match the required state, which is great. Kubernetes is great at just doing its own thing. And the same mechanism is used by KubeVirt. Thus, KubeVirt delivers three things to provide the new functionality. We have additional types, so-called custom resource definition, CRD, are added to Kubernetes API. So we'll see our own custom CRD later on. Additional controllers for cluster-wide logic associated with these new types. Then we have additional daemons for node-specific logic associated with the new types. Once all three steps have been completed, you will be able to create new objects of this new type in Kubernetes, VMIs in our case. And the new controllers take care to get the VMIs scheduled on the same host. And a daemon, the virt handler, is taking care of a host alongside the kubelet to launch the VMI and configure it until it matches the required state. Let's kind of take a look. One final note, both controllers and daemons are running as pods or similar on top of the Kubernetes cluster and are not installed alongside it. The type is, as said before, even defined inside the Kubernetes API server. This allows users to speak to Kubernetes but modify VMIs. What does this mean? So we're actually talking to Kubernetes, and Kubernetes through the API server is talking to the virtual controllers, which in turn handle our virtual machines, right? Like in the picture, we can clearly see which are KubeVirt components and which are Kubernetes components. We can see that they are inside of a pod, but they are not handled by Kubernetes, they are handled by the virtual controller, which is talking to the API server of Kubernetes, which we talk to. So we are talking, again, to say this again, we're talking to Kubernetes, but then the control over the actions, the KubeVirt takes over and handles the virtual machines. Here's a little different picture here. We have two worker nodes, the master node, and as you guys can see, we have an app with just virtual machines. We have a hybrid with virtual machines and containers, which I think maybe the biggest power of KubeVirt lies. And then we have an application with just containers. So now let's talk about the application layer. So far, is there any questions? Does anybody know what we're talking about? Anything on YouTube?
Yeah, Stefan, can we go back to that previous slide? And one previous to there. So yeah, I was just looking at this and I just want to make sure I'm understanding correctly. Where is that outermost layer on the right? So that single node that one. Can there be more than one of those nodes managed by this KubeVirt service? Or
like I mentioned, KubeVirt doesn't control the node. The node and the pods are managed by Kubernetes, right?
Mm-hmm.
Inside the pods, we have the handlers, and which are controlled by the controller and the virtual API, which are inside, which is just an object in the API server. Like I said, a pod is just an object in Kubernetes with the type pod. And we have custom definitions, which is virtual machines, which are an object in the virtual API. So we're talking to the API server, which talks to the virtual API, which then takes care of the functionality of that object. And we're going to call it virtual machine. And it's consistent of virtual machine or virtual machine instance, VMIs. So the node and the pods and the Docker runtime, we can ignore that now, is all managed by Kubernetes. So if you can have multiple nodes and all of that, but that still goes in the logic of Kubernetes.
So there would then just be these KubeVirt objects within each Kubernetes node, sort of supplying the KubeVirt management and control over the Kubernetes node.
Yeah, they run on the node, but they have their own functionality inside of the pods, which are on the node.
Right. So essentially, this whole Kubernetes node can be replicated like you can have basically as many of these nodes as you have in your cluster, and you're going to be able to control all of them through KubeVirt. Or excuse me, use the KubeVirt service in all of the nodes.
Yeah, I mean, you manage them through the API server of Kubernetes, which then in turn by the controller. But yeah, it's the logic of Kubernetes. You can have as much of the node as you want, and then you have one master node which delegates the work to the worker nodes. In turn, they distribute the work throughout your nodes. Usually you have a bunch of nodes. Like in the previous, when I was doing on DigitalOcean, I had 3 nodes, and I was talking to only one node, which is the master node, and then that one node handles everything else. So that's what you're referring to is the logic of Kubernetes.
Awesome. So I guess my last question here is about those master nodes, and you can definitely delay and answer this later if that's in a better spot. But with the master non-master architecture, does KubeVirt get around the sort of, or does maybe this is something inherent to Kubernetes, but is there the ability to like reassign the master node in case you get that node in particular failing?
That's a really good question. I haven't really thought about that. I always assume there is only one master node which talks to the worker nodes, but then which node you're talking to directly, I'm not sure. Is it the way that you can talk to any of the three nodes and then there will be a designated master node within each node, or then there's one? I would assume the first one. But that's a very good question. I'm not sure, I'll say, but I think that there is only one master node and you can't reassign that master node to another.
Okay, thanks. I think an example of reassignment would be like Spark nodes can elect a new master if the master node fails, something like that. But I appreciate you fielding that question. Thank you.
Thank you, Nick. Yeah, maybe inside of the node. Yeah. Okay. Let's kind of go down to application layout. You know, we kind of have the KubeVirt components, which is the controller, the handler, the library virtual D. And we kind of take a look at the controller handler. We kind of talked about those, and we will take a look at them, you know, when they're deployed. No. So I guess many master nodes. Okay, so yeah, Merle mentioned, yeah, as he mentioned, yeah, there can be many master nodes. I'm not sure if you can reassign them, but yeah. KubeVirt components, KubeVirt managed pods, and custom resources, which are virtual machine and virtual machine instances. The virtual machine instance is the custom resource that represents the basic and thermal building block of an instance. In a lot of cases, this object won't be created directly by the user, but by a high-level resource. High-level resources for VMIs can be virtual machine, stateful virtual machine that can be stopped and started while keeping the VM data and state, and virtual machine instance replica set, similar to pods, replica sets, a group of infernal VMIs with similar configuration defined in a template. Native workloads. So KubeVirt is deployed on top of Kubernetes cluster. This means that you can continue to run your Kubernetes native workloads next to the VMIs managed through KubeVirt. Furthermore, if you can run native workloads and you have KubeVirt installed, you should be able to run VM-based workloads too. For example, application operators should not require additional permissions to use cluster features for VMs, compared to using that feature within a plain pod. Security-wise, installing and using KubeVirt must not grant users any permissions they do not already have regarding the native workloads. For example, a non-privileged application operator must never gain access to privileged spot by using a KubeVirt feature, kind of like the security is managed by you. So finally, let's kind of talk about virtual machine. So virtual machine provides additional management capabilities to a virtual machine instance inside the cluster. That includes ABI stability, start, stop, and restart capabilities on the controller level, offline configuration change with propagation to virtual machine instance recreation, and then to ensure that the virtual machine instance is running if it should be running. It focuses on a one-to-one relationship between the controller instance and a virtual machine instance. In many ways, it's very similar to stateful set. Yeah, so let's talk about a little about virtual machines. The way they are handled using KubeVirt is they have their own KubeVirt CLI. And I'll just get the virtual CTL tool, client tool. So it's basically a kubectl plugin, which we use to handle those. And we can say, let me see.
Hey, Stefan, do you mind zooming in?
So,
Chance.
so yeah, I didn't have that much time to actually play around with the virtual machines and connect them to containers, see how they interact with each other. I should be something in the future, but I'm gonna quickly talk about how to get started with KubeVirt, and what you need to, what it actually is, because we can kind of like take a look at it better through just hands-on. kubectl Virt is the virtctl client tool. Basically, virtual machine instance operations can be performed with the stock kubectl utility. However, the virtctl binary utility is required to use advanced features such as serial and graphical console access. It also provides convenience command for starting and stopping virtual machines. Like we can see here, we have the start and stop, live migrating virtual machine instances and canceling live migrations, uploading virtual machine disk images. So we can kind of like take a look at the available commands of this this plugin that helps manage the functionality of the virtual machines, right? So yeah, we can migrate. Like I said, we can migrate. We can cancel the migration. We can pause the virtual machine, and like a bunch of stuff that's high-level abstractions of just doing things with kubectl. So once to install KubeVirt, it's really simple. You just need to install 2 YAML files, and they're provided to you in the documentation. And if we kind of take a closer look at it, it creates a new namespace, KubeVirt. KubeVirt. So as we see, like we talked about, we have the virtual API, the controller, the handler, and the operator. These are all in the namespace KubeVirt. And as we can see in the YAML file, we are declaring this namespace with the name KubeVirt. Now we are taking a look at the custom resource definition. And it's just, a bunch of stuff here that they've built for us. I'm not going to go too much into it because some of this stuff is more low level. We have the priority class, the cluster roles, service account, and I think we had somewhere a deployment here. So deployment, yeah, weirdly enough, they're just doing it as a Kubernetes deployment. They have not, I have not seen a Helm chart for this. Guessing it's not necessary for this at this time. I'm sure maybe in the future, if they think of expanding this, there will be a Helm chart. We can just install it with one command. But for now, you just need to apply this operator and this CR, the YAML file. You can see this is a kind KubeVirt, and it's named KubeVirt in the names KubeVirt. And that's it. You have spun up the KubeVirt resources necessary to handle any virtual machine, right? And then if you want, you can just run a virtual machine instance by running this YAML file. And I tried running this. I was having a little bit of trouble with it, getting it to start. I didn't have that much time to go too much into it, but I'm sure it's it's not that hard to get it starting. And if we take a look at it, we have the resources, how much we're giving it. We have the storage here. Yep, some of this stuff it's the first time I'm seeing them. And this is a virtual machine YAML file. It's a little bit different, and you can find these resources in the documentation of KubeVirt, and you can try around playing with it. But like I said, kubectl virt is the command that it can help you out, and we can say so there was pods and there was virtual machines. Let's see. Okay, so as you can see, there's a new resource now in Kubernetes called VMIs, and we can take a look at the life cycles of it. So we can, like I said, we can start and stop them. We can pause them. We can, take a look at what they're doing, maybe describe. I haven't tried. Basically what we see in the YAML file. Let me see. There was some on pause, listing virtual machines, get VMIs. Yeah, so then these are all going to be stored in the namespace KubeVirt. So, when you're working with it, make sure you are in the right namespace and not looking for somewhere else. There is a virtual machine that I showed you from here. And just a bunch of more information can be found here on the functionality of the virtual machines through KubeVirt. It will be really interesting to do a kind of hybrid setup using Kubernetes containers and KubeVirt to manage that and the virtual machine. But as of now, still haven't really dig deep into this. I would definitely be looking into this in the future. But if anybody has anything that can add for now, or if anybody has any questions, feel free to shoot here at this time.
Yeah, I have one question. So if you go to the diagram, yeah, so here we have the, like, per pod, we have the, essentially the configuration of the stuff that you define your VMI, right? So I guess, how does the structure work when you're defining a VMI? So like, where do you put in parameters that connect it to the Virt handler or the Virt API? Like, is there, in the YAML file, it's like you set the connections there, or how does it eventually, I guess the question is, how does it all link up?
Yeah, it's a good question. So through kubectl, right? We actually, like I said, we talk with the API server. So we talk to the Kubernetes cluster, and Kubernetes cluster manages your resources, right? In this case, the virtual controller and virtual API are KubeVirt components, but they're resources of Kubernetes. So you're managing Kubernetes resources, right? So like here, they are pods here. And through these pods, these contain the functionality of the virtual machines, right? So you're talking to the KubeVirt components through the Kubernetes components. And the way basically they work together, and the way that it's structured is not something that I really can dig into deep. Maybe the developers or the ones who created can really give us some more insight of how they managed to do this, which I think is pretty interesting and pretty cool. But as of how it, high level how it works, again, you have the KubeVirt resources, which talk to the Kubernetes resources, which are, which you talk to, basically.
Okay, and then because I guess all of these things are, because it's running, the VMI is running on the pod, is it possible to control like the Virt controller, Virt API, similar to how you can control configurations in the UI?
What specifically are you referring to? Are we able to control the virtual machines resources?
Yeah, so like I know you've shown in the past that you can adjust configurations within the UI of the Kubernetes dashboard. Is it possible to see or potentially make changes for like the controllers or sorry.
Yeah, of course you can, because there are resources of Kubernetes, and you should be able to change specific things about them. But I don't think you should, especially in the controller and API, because they're specifically set to manage those. And I think if you change them, they might impact the performance or the expected outcome of how you handle those virtual machines. So to answer your question, yes, you can't actually you can mess around with anything, but I wouldn't do it if I'm actually like trying to use this. If I'm trying to maybe like play around with it and try something new to build out of this, then yeah, maybe mess with the controller and change specifications in it.
Got it, thanks.
Let me see if I can show that.
Are there any questions remaining from the YouTube side? Feel free to drop them in the real-time chat and we'll get them shown to Stefan as well. Okay, doesn't look like there's any more questions. Thank you, Stefan, for giving this talk on KubeVirt. I'm definitely interested in seeing all the more capabilities, especially that scenario that you mentioned, the hybrid scenario. And with that, we'll wrap up Data Engineers Lunch. Thank you everyone for joining us. All these videos are live streamed directly to YouTube. So don't forget to like and subscribe if you're watching on YouTube, and turn on the notification bell so that way you can get notified whenever we do go live or whenever a live stream is published to YouTube so you can catch it as soon as possible. Thank you. Take care.